Dr. Zhang, you may begin.
Okay. Can everyone hear me? This is Alice from Peking University. Today is my great honor to share with you my experience, my adventure in a micro-nano field, and my personal life. This is one of my pictures. I hope it looks exactly, because it was taken last year. So my Chinese name was Zhang Haixia. My English name is Alice. So I'm a professor in Microelectronics at Peking University. For start, to let everyone know me, I will try, first to explain my Chinese name. Last name is Zhang. As you see, this was the most popular Chinese name. So you know how popular it is? We have 100 million people have this same last name. So maybe you couldn't imagine the numbers, but that's true. My first name was Haixia. Hai was meaning the ocean or the sea. Xia was the sunshine on the ocean. So yeah, my name was pretty nice, right? It's sunshine on the ocean. So yeah, but this name actually gave me a lot of troubles at the very beginning when I was young kids. You know why? Because it's too complicated. And always listed in the last on the page. So I'm unhappy. So when I learned English, so I gave myself a very simple name, Alice. Why Alice? Because start an A. So and very soundingly. So everyone can remember this name very easily. So the first name was Alice. So that's my English name. Actually, funny story is later, I have almost the same adventure as this Alice. So today I give you some examples for my life, this Chinese Alice adventures. My hometown was in Henan, so it's quite in the center of China. Anyang is a small city. You may never heard about it, but you should have heard of the oracle. Oracle is one of the oldest characters in Chinese. So my hometown was actually the oldest capital city in Chinese history. So they have about more than 5,000 years history. So it was a pretty old town. But this pretty old province also has the same problem. It has too many people. So you have to be very brave then to grow up. So yeah, when I was a young girl, I was always this catcher maker, stand out to be outstanding. That's at the very beginning I was learned. You have to be brave. You have to always to be raise your hands, ask questions and make some questions. Then you'll be stand out in your class. That's at the very beginning. When I grew up, I went to university. Yeah, that's trying everything exciting. My university was in Wuhan. It's the south part of China. It's full of lakes, rivers. So it's full of water. I got my Ph.D. there. So the universities are pretty funny. We have a lot of, fun sports. We have a lot of fun stuff. And this university is very strong on the science and technology. So that time I said I got my Ph.D. Actually, there were some stories. Before I got a Ph.D., everyone asked you, okay, you want family or you want Ph.D. degree? So in China, or maybe not only in China, in many, countries, there was a problem for the young lady. You want to have married with someone, you are married with your degree. Like these pictures is very funny, but it's true. Why it is difficult, for someone to accept a young lady with Ph.D. as his wife. But I'm quite lucky. I got one guy. Is my mentor. He's happy to, have me. So, and we have a very nice family. So I also got my Ph.D. I say I want both. After that, I went to Tsinghua University, top university in China, to get my postdoc. You can see that I got all my degree and education in China. So that means the soft shell turtle. In China, we have a special name for this, is Triboelectric. That's local educated people. So I was a soft shell turtle. So and then I stayed a few years in the U.S. And that time I got one word, is the best word in my life. It really changed me a lot. Because one day I met some problems, so I want to talk to someone, but I'm very nervous about that, because that time I think my English is not good, not very good. Everything was not perfect, so I'm nervous on this. But my supervisor said, okay, Alice, don't worry about it. You go ahead, just do it, you win. So I take these words, I mean, it's really the word changed my life. After that, I never worry about anything. I never feel to do anything, because I know that if you just brave to do something, then you get it. So that's the best word I heard, in my education and in my training. Then I got a job at Peking University. Okay, Peking University is one of the best university in Beijing. So Peking University also have a name as PKU. It's play killer with you. So what that means is, you have to be very strong. Because in top university, if you're not very strong, you will be killed by others. So yeah, we're always joking on this name, but this name is quite funny, to have a, joke with the faculty here. Yeah, that's my life. That's my story for my education. You can see that when I was working in Peking University for more than 10 years, so I got that my self-empowering life is I always, have a time to play families, my academic lives, and also I put a lot of attention on the educations. And that's how I grew up and how I was, educated and got a job. I mean, if I have some questions, I'd like to take it. Kiana, can you hear me?
Yes, I hear you perfectly. Thank you.
Yeah. Shall I go, forward to some other part, or take some questions here?
What we can do is we can actually continue, and then at the end, if anyone has any questions, we'll take all the questions at the end.
Okay, that's nice. Okay, then I will go ahead to finish this one. Okay. Cool. Yeah. Here you can see that I, got my life with happy families. I have 4 generations people living together as a quite big families and very happy. Yeah, I work with my students very closely to get very interested in research work and also put more attention on education. Then I will tell you something for my story with my students and for the education. So how choose my major? When I was a student, the first I got degree was in the mechanical engineering. That time, in China was really popular for they got a degree in mechanical engineering because they need many engineers and many workers, and a lot of big plant needed the people. So, but later in my study, so I read one of the book was the articles is there is plenty room at the bottom. That's by Richard Feynman. So it's quite famous. Then everyone was moving to the Silicon Valley, the silicon wafers, the microelectronics. Looks like they changed the whole world. So in China, even maybe 10 or 20 years later, but that's also a very big trend. The people was moving to this part. So we do more of silicons. Can we do something in silicons for the microelectronics and also for the mechanical engineer? There were a lot of things to do. So because we live in a magical world, you see that we from bottom to the top, we have a lot of things to do, and there are a lot of magical stories here. If we look down in this one, this pretty, pictures, we can see that it was magic functions because you just blow it, it can go everywhere. It can, be a seed to grow up everywhere. So that's more beauty, and this is smaller size. That's more functions with these micro and nano scales. So I start to study this for the unique functions about micro and nano structures in this bottom line. So see if anything we can do. So that you can see from these pictures, they are really amazing. You can see the butterflies. It can change colors when its vibration is, it's fly. So you can see that how it make it, how it changes the colors. It's because the structure is on it, on the surface. So once it vibrated, so it will, in the different frequency, you will see that the light was shining. So there was too many things, like this can, flow on the water. So why it can stay on the water? It's because it's fit with the micro-nano structures. These structures also make it, very smoothly and move very smoothly because it's hydrophilic. So there are too many, unique functions by these micro and nano durable structures. That time we see, can we make something by this? Can we handmade this or man-made? Of course, it is possible, and it is a lot of people was learning this. You see this? We use two methods. One was in the microelectronics. They always use this top-down skills. This top-down skill, it means the, user layout, the lithography, all these procedures to make the small size. It can make to micro scales, even down to nano scales. But it's very mass production. And but when it goes down to the nano scales, it gives me not only give me, it gives the people a lot of difficulties. One is the cost. The cost is huge, and another is for the fabrication process. It's very complicated. The second part, how to make the nano structure on the magnet, is for the bottom up. This was doing by the nature very frequently, very useful. That's the bio staff, and also for the chemistry, they are good at this. But this method, they can grow something, from solution. They could grow some from some small seeds. They even can, do some composition. But the difficulty for this to be mass production, and the cost is very large. So these two methods to give us two kind of approach, but both of the approach have some limitations. Is that possible to make something, simple as this with mass production, microstructures by the top-down procedure? And another is making the nano, structures on the top with unique functions at the same time. Is that possible to make this? Make this quite, looks perfect micro-nano structures. So if we can make this with the mass production, with these unique functions, they will give a lot of, potential applications. So I try this. This picture was made by my group. So we use one method was, popular in the microelectronics fabrications in the clean room. We use the DRE process. We can control the process. We can make the, microstructures in the whole wafer. We also can, in one process make the nanostructures on top of these microstructures. You see these pictures, on the the two pictures was microstructures before the nano structure on the top. The second is the nanostructures already made on the top. This was done in one process, in one step. You don't need to add any more steps. So it's quite cheap. You don't need the nano, layout. So that saves a lot of money. And look down, if you have 3 dimensions, it can cover even the sidewall very well. So this method is very interesting and is very useful because it is very controllable. It's also compatible with the, microelectronics process, can be mass production. It also can be used to many, other materials. This picture shows you we transfer the silicon models to the flexible materials. We use a solution and then pull down, the silicon model into the solution, and then when it gets a solidization and just peel it, you can transfer this micro-nano structure onto these flexible materials where it copies the micro-nano structures on the top of the flexible material. So this can transfer to many different kind of flexible materials. So the silicon mold can be reduced or can be reused many times. So this was some examples. You see that the flexible materials with the micro-nano durable structures, it's pretty good, and it's almost transparent. The transparent give you another, good application is for many displays, different kind of displays. And if you treated the surface of these micro-nano structures, you can get very good functions. This was a property study of these micro-nano structures. First, you see this one is a liquid property. You see the contact angle is very good. The rotated angle is pretty low. So that means the water or the drop of the solution couldn't stand on the surface. It will be rolled out, kicked out by the surface. But if you treat the surface with other, gas or other things, you can see that it can be totally hydrophilic. So this surface can be treated, can be switchable. You can easily be hydrophilic or hydrophobic. So that means you can design the surface. If you want it to stock the water, you can make it. If you want it, remove the water, you can also make another part. This can be done in the same, surface. This also can be done in the same wafers. And the different pattern on the surface can make you, with different kind of properties of this. So this very interesting structure we made a lot about this. Actually, we got the questions. So you made so many, and the different kind of micro-nano structures. You made it looks perfect. You made it with different functions, but where you use it, which part is the most useful part for these micro-nano durable structures? You can give one answer. My answer is I want to use it in the power. Because this picture, maybe you will love it. You see this guy was yelling because his cell phone was power off. As today, everyone has their smartphone, has their cell phone. It's already become one, very important kind of cell in your body. So if your cell phone was, power off, your feelings, you disappeared in this world. So you have to, make it always powerful. So how can we make it? Now always the battery, always charging the battery. So if you couldn't find the place to charging your battery, your feelings you would disappear. So I'm thinking, is that possible to use our daily energy? Like I'm working, I'm typing, or I'm breathing or something. Yeah, if I can use all this energy transfer into the electricity, that will, make my smartphone very safe and also make myself very safe. Can we, powering by myself? Yeah, so yeah, I try to use all these structures to make this. Here is the stories about this. Yeah, every day you may met this, the electrostatic phenomena, especially in winter, like in Beijing, it's pretty dry. So if you touch your hair, you can feel that you get, you get charged. So is that possible to use this Triboelectric Mechanism? Yeah, it is. That's possible to use it. You see this picture with two kind of different materials. It all was the polymer materials with different charging property. So yeah, if you're pushing them together or if you are separating them, so you can easily to get the electrons, running through. So if you got two electrodes on top and the bottom, so you can get the electrons to set up a follow. This can be a battery. So this phenomenon was utilized first by Professor Wang, Zhongling Wang in Georgia Tech. So he made the triboelectric generators first. For us, we see that, oh yes, that's cool, because we can make micro-nano durable structures on flexible material, on many different kinds of flexible materials. So this kind of complicated surface, they will enlarge the triboelectric mechanics very much. So if we can use our fabrication process into these new generators, they'll enhance the generator's function or the performance very much. So we started this work, 2.5 years ago. You can see this was the first structure we started was a 3 sandwich structure with a 3D. In between was aluminum used as one as electrode. So the upper and the lower was the PDMS with micro-nano durable structures, and the blue one was ITO and PET, so used as electrodes. So you can see this was one model about these devices. When it's pushing together or it's releasing, you can see the electrons was follow as the current to go through. So this was the mechanics. That's a fabrication. As I said, it was pretty, easy. You can see this, the blue one was the silicon mold. We make micro-nano durable structures on this silicon mold by the DRE process. Then we use it transfer process to transfer to the different kind of flexible materials. It covers the micro-nano structures. And this was the SEM pictures. You can see that with different patterns, either parameter patterns or the group patterns. So on the top of this structures was, full of the nano microstructures. So this was the testing result. It's pretty, surprise, because you see that B was a flat form, C was with a nano, power nanostructures, D, E was with different kind of micro-nano durable structures. The output was pretty high. The voltage can go up to 500, and also the current can be up to more than 100 microvolts, microampere. So that's very, very good. That means you can driving a lot of things. And you can even working in the very low frequency, like 5 or 6, less than 10. So they have a very pretty, stable output. It can charge capacitors in a very short time and with a very small scale. So we use this one to lighting LEDs, and it's easy to light in many 5 LEDs by a very small size. It's also, because it has a big current, very large current, so it can be driving the electrodes. This electrodes was used for the, retina in the eyes. So many people have this problem, so they need the electrodes underneath the retina then to stimulate this. So we use this one as, a self-powering stimulating electrodes and underneath the eyes. So it has very nice results. So this was give us a lot of confidence. So we can use the micro-nano structures to get very good results for the generator. As we said, we can just use typing, we can just use, vibrations to get good results. Then is that possible to get even more stable output? This one would give you an answer. We use this structure as a static structures, several layers. So during between that has both sides with micro-nano structures. So it can be get the continuous square wave output. The voltage higher than 10 volts. What's that meaning? That meaning you can drive in many micro and nano devices, like the micro accelerometers, the gyroscope, pressure sensors. It's all in your range. You can, work on this. So this also, can be used for many maps, sensors, and devices in the systems. So it's a very nice story. And is that possible to make it more cheap and more mass production? The answer is yes. See, this one we use the most popular fabrication process, the print circuit board, so PCB. The flexible printer PCB was quite popular use in many fields, and the fabrication method is pretty, low. And the price is pretty low. So we use this commercialized process to fabricate the microstructures, and then with our some afterwards treatment on the surface to get the nanostructures, and we easily to get these devices. You see the small size on the left, on the right side. The 2 fingers was typing on this micro. Triboelectric generators, and you see that it can be lighting for more than 100 LEDs. So that means the output voltage and the output power is pretty high, but the size is small, and this process also gives you a very powerful support, because it can be fabricated together with other, the microelectronic devices, the chips. You can mount it on this, self-powering sheet. So it can be used in many fields. That's one good way. And this paper was just published last year, but till this year we already got more than 1,000 people have downloaded and viewed these papers, and they got a lot of attention. So we're quite proud of this. For another applications consideration is for these triboelectric generators, I said before, you normally need 2 layer or even more. So, but if you want to use in your smartphone, so that's quite not easy to be a mount on that. Is that possible to make it more easy, like to use my touching or moving, on my smartphone, the screen? Yes, the answer is yes. My student make one transparent, the micro-nano durable structures on the surface, and got the electrodes on that, and use your finger as another natural part for the tribo functions. So this can put on top on the smartphone screen. So this can also get a very good result, and this also can get applications on like iPad and other kind of touchscreen screens and touchscreen devices. And this was for even going forward for the single surface, the triboelectric generators on the human body, because now today everyone talk about the varying electronics. So if you can vary a self-powering electronics, which can a good story for you. So we fabricated this on single surface electrical generators on the use a human body as another part. So it got a pretty good result, and it's also useful. This was used your mouse. So if you got your mouse and the mouse pad on the underneath, so it also can be, calculate or harvest the energy for your mouse moving and all this kind of touching. It's also can get a lot of energy to support your smaller, devices. And this was a hybrid, because we want to get more energy. We want to get more the better performance. So we hybrided these triboelectric generators with piezoelectric generators. This was one example with the R shape. This R shape on top is the PVDF layers, the thin film, is with very high piezoelectrical, the functions or properties. Underneath was the PDMS with Micro-Nano structures. It can touch down with, get Triboelectric generators output, also get the piezoelectric generators output. So this can be enhanced the whole devices, the output. This also get a very good result and applications like you see can put on your PC keyboard table and keyboard on other kind of keyboard devices. This was hybrid with the magnetic, structures. This with magnets inside also can be very high to enhance your output. This paper was published, this year, and also got a lot of attention on that. And this was more efforts to try to enhance about the output of this triboelectric generators. We function or treat the surface, and we're doing different kind of function materials on that, and then can get very much output. Also can be used as active sensors. As here, one example is for the humidity. So these sensors with different kind of on the top of the surface, the materials changing of the humidity of changing with this, triple generators. So it can be used as sensors too. And this was the kind of different applications we are shooting for. So firstly is energy pad. Just I say that this was fabricated by the PCB process. So the flexible PCB process can give you a lot of, low-cost mass production benefits on this. This can be useful for the IoT, that means Internet of Things. It needs many smart sensors and many, different nodes, testing or sensing nodes. So this can help you to get a self-powering system for the IoT nodes. Yeah, in the middle, it was the thin film, the single film, because it was transparent. It's also used for this portable electronics. Can put on the skin, can put on the back, can harvest more, energy from your daily moving and your daily life to powering yourself. The second is the third one is for the E-sheet, because it can be used in the quite large, surface areas. This was one kind of put down in your home. So when you are moving on it, running on it, or walking on it, you can generate the power by yourself. So this also can be a burning system, can be for safety, securities. So this was just a few examples for how we use it and how we can, use this one. And here is my students, actually. This work was pretty interesting and a surprise for everyone. So they win a lot of honors. This picture was boys and the girls with their product go to the Geneva Innovation. So they win the gold medal, and it was a very happy day. You see the demonstration is for, this was electrical piano. So they put the triple electrical generators down the table so they can recording all their performance. And they also got some other examples showing on that. And this was the last part of my talk. Is I show one of the results for my research work. The students get very good results, feeling very happy. So actually, I put more of my attention on my education. I try to nursing all these young generations, try to have a very exciting life, and not only with their working in the lab every day, every night, but they also need more to, put attention on their innovation, on their new life. So this was one part of my work. as I said, the third part was education. So the education part, I tried to introduce one contest. I was initiated 8 years ago, and this contest was ICAN, the name. It's an international contest of applications in nano and micro technologies. The short name was ICAN. It's quite easy to recognize, and it's quite easy to remember, because ICAN, it was a contest to try to get the students into innovation in the micro-nano field. Here is our mission and vision of ICAN. We try to promoting the youth innovation spirit. In China, so I can feel that we have many, very large numbers of young generations, but more students not confident with themselves. More students don't think they are very innovative. So it's maybe in many other countries the same thing, because the contest, I talk with many other professors, and so we try to promote this in the youth generation for innovation. We try to nursing the youth inventors worldwide. And also we want to creating the opportunities of the high tech. And we try to set up an eco platform for innovations. And it's from the education to the market, supermarket, to not the supermarket, but to the market. So this was what we're trying to do. See what we did. That's ICAN's history. Actually, I said that I initiated this contest in China 8 years ago. So it's quite amazing. We have the students, the numbers will go up so rapidly. You see that numbers. This year we have 18,000 students involved. That's a pretty large numbers. That's from many, different countries, different universities. So every year this contest become a huge, event. And this was the contest, the blueprint, the past in the last 8 years. 2007 I was initiated in China, and 2010 it became an international innovation event for the young generation. Now every year we have many thousand students from many places. You can see that this was in the last few years for the international contest was going on. The first year was in Xiamen in China, then following was in Beijing 2 years, and then in Barcelona was last year, Barcelona, and then in Shanghai this year was Japan, and next year will be Alaska in U.S. So then we'll go to Paris, to Europe, in 2016. So we really very happy with this result. I was working on this ICAN contest for 8 years, and I was working with different, students from different countries and all the professors from different places. We can feel that we have the same dream. We want all the young generation can be more proud of their innovation and can have more proud of a more innovation project to come out, more product to come out. We want the young students, to do something new, not only in this field, but also in other fields or in their life. So this contest was really growing well, and we want to have more and more students jump in. That's not only a contest, that's also a platform for everyone to show their innovation. And if you are students, you can work in, in your project innovation to show. If you are professor, you can encourage your students to involve. So this is a quite open platform for everyone. So low down was the pictures we are taking in many different places. So it's very happy and very happy journeys for this. Next year, I said 2015, we will have it in Alaska. So that's where far is the place, but it is a very nice place, right? With snow mountains, with clean lake. Yeah, I think it will be the best chance to go to Alaska, you know, in your life, and with ICAN project. If you have some students or some ideas, you can contact me. Yeah, you see that this is my happy group. I mean, maybe you couldn't imagine this picture was an SEM picture. Then when painting on it, we make it like, you know, very nice pictures for the space. So that's all the lovely days with my students. Now some of them are already graduated, some of them stay here, so all over the world. So we have many happy times. So this lab was named Alice Wonder Lab. So you can either find it by this link. And this is Peking University, a very nice place. You can see that this tower, the lake, and the colorful trees. So yeah, you will feel that it's a very lovely place. In contact, we always say, yes, I can. Now I say to you, yes, I can welcome you to go to PKU and welcome you, you know, visit our place. If you have some chance to meet us, so be sure to contact me. Okay, that's all of my presentation. I think I can, you know, move to some questions part. Okay. Thank you very much. Hi, Kiana. Hello.
Thank you, Dr. Alice.
Hi, Kiana.
Can everyone hear? Can everyone hear me okay?
Okay. I hope it's still there.
I'm going to transfer this. If anyone has any questions, please post your questions in the chat.
Hello.
I'm actually going to send any of your questions over to you for you to respond to.
Mm-hmm. Oh. Awesome. The question is, why did you decide to become an engineer? That's a very nice question. Actually, in my slides, I will say that when I was in the college, I chose mechanical engineering as my major because in China that time is quite popular and you know, for the young people to be an engineer because there were a lot of openings. They have just you know, start the country, you know, to rebuild everything. So it need a lot of engineers. So that's a lot of students do that. And as a female, you know, also it's a dream to do something to even better, you know, than your boyfriend. So yeah, I choose engineers to be my major. That's quite obvious reason. Okay, then the next question is, what are a few of your motivators? What makes you excited about doing what you do? I answer the second questions. Actually, my motivator and the excited, you know, is the same thing. Now I'm focused more on my research and education. Why? Because of my students. Actually, I met many students in different countries and in different places, and from the primary school to the, you know, a graduate school. So all the students, they gave me one feeling. I need a good teacher. I need to get more information. I want to be something, I want to be someone. So as a teacher, as a professor, I mean, that's my job. So I need to do something. I need to teach them. I need to tell them, what they should do. So my motivator is my students. Every day, everything, so that's it, exactly. What really makes me exciting is the students' reply. I give you one example. As ICAN contest was finished every year, so many students would come over to me, say, Alice, now I feeling, yes, I can. That time was the best time of my life. So that's the most, excited things about me. So, I mean, I really feelings, I like this. Okay, there has another question is, if a person wish to enter your field, what characters of education background must have? Actually, Micro-Nano field, it's the research always from two fields. One was microelectronics, electronics field. Another was from mechanical engineering field. So ME and EE are both qualified to get in this field. And what kind of education background? If you want to, got some academic, some like faculty job, I mean, Ph.D. is the bottom line. If you want to go to the industry, most, prefer for master degree or something, So as I may add one, extra answers here. It's many female students in this field, and many female faculties was really outstanding in this field. So yeah, they're welcome. Okay, great. Yeah, this question is what is the most spectacular things that you have accomplished in your career? I mean, the most, spectacular things till now, I mean, it's ICAN. Because ICAN contest really changed many students' life, also many faculties like me. So, yeah, I got more feelings here. I also got my research involved in this contest because the students can make something really interesting, can make something really good, and can make it into market. So I think that's meaningful for why you're doing research, why you're doing so much hard work. Yeah, that's the most interesting things. Okay, what is the best advice you have ever received in your professional? Oh God, this was an interesting question. How to answer that? As I said, the best word I have heard or have got is go ahead, just do it. This was a very interesting story. I think many people has met this kind of problem before, because when you are young, you're always not feeling so confident. You're always thinking you are not good enough. You are not ready enough. So that time I really exactly want to do something, but I'm really afraid because I think I'm not qualified. My English is not good. My background is not that strong, and my preparation is not enough. So I feel really nervous. But I told my supervisor, I said that my nervous. And then he said, okay, Alice, no, you don't need to worry about it. You got the idea. You go ahead. Just do it. You already win. So that's the best words I have ever heard. So that's the best advice in my difficulty time. I mean, later I always tell my students, if you have some good ideas, go ahead, just do it. all the difficulty is not a problem. The most important thing is you go ahead and do it. Yeah, that's the best words I have ever heard. I mean, it's also used for everyone. Okay, what trends do you see in your industry? Oh my God, micro-nano field now is the most popular field. You can see many things what's happening now, but in the future, I mean, there are at least two fields need you put more attention. One is in the bio, because many things will be related with the bio, especially in micro-nano field. So you're doing something in the bottom. You're doing something, quite small. What is the real application? Actually, it's the major benefit for yourself in the medicine or in the research, for your body or for everything. So, I mean, this was one big trend. So try to relate it with all this bio stuff. And another trend is for the energy. You can see that the whole world is more worried about the energy crisis. So energy has become a big issue. Not only the big one, but also very small one. Like I said, smartphone and other very smaller, devices or systems or electronics on our field. So we all need energies. So this micro energy also is a very popular field in the future. So I mean, if you are, interested to be billionaires, you must put attention, in these two fields. That will give you many chances to, be really rich. So, any more questions? Here is another one. What's your way to stay balanced with all your commitments and workout duties? Balance. Okay, if you say about balance for commitment, work duty, or even in family, as a woman, as a wife, as a mother, or as a doctor, or even in your job as a professor, teacher, I mean, that's always very difficult to make balance. But, I mean, put your heart there. If you really care about that, so then you can make a deal. As me, I really put many efforts in my work and in my research, in my education, all these fields. So I have many times to, go out and not stay in home. But I still have a very good relationship with my family, because I always tell them, okay, like my daughter, Mommy love you. Mommy take care of you. So, yeah, that's I try to make balance, but I know I'm not really good at to make balance, but I put my heart on that. So, till now, it's still okay, yeah. So, but this was always a question for the female researchers. I mean, everyone, if you are a female student or a female faculty, yeah, that's always, you need to think about it. You need to not only, put all your energy in your work, you need also put attention in your family and take care about them. Another question is, what are a few of your motivators? I have answered this, okay, before. So I will still to say more about the family and the, and the work, the relationship. Actually, I met many of the female faculties in different countries. I mean, we talk about this. So you tried your best. So with a family, you have your duties. You couldn't, you couldn't say you don't have duties. Others all should support you, but you should be left with them and should love them. So if you couldn't, put many of your time in your home, but you still need to, do something for your home and to keep this, relationship. Another thing is for your work. Many people, I mean, especially in Asia or in other places, they always female is not very easy to find a good job, but you need to really have a equal, the results. you will have a good result and you will have the good work. Okay, good. Oh my God. Okay, that's almost the time, and it's almost, after all the questions, I mean, 1 hour is really, not a long time, but we can share many things. I hope this short sharing and this story can help you in your near future and in your career. Okay, thank you very much. Hopefully see you next time. Hello, Kiana? Hello, Kiana?
Hello, Dr. Zhang.
Yeah,
Okay.
can we, stop here?
Yes, I would like to say thank you again for taking part in today's live chat. I truly appreciate it. I actually learned a lot as well, and I hope everyone that joined has learned something and was able to take something away from today's meeting. I would like to say thank you to the IEEE Electron Devices Society, as well as the IEEE Nanotechnology Council, and for participating in this Women in Engineering session. We appreciate the support of the societies, and Dr. Alice Zhang, thank you again. Amazing presentation, and we look forward to having more presentations with you in the future. Thank you.
Okay, thank you very much for your hosting this, and we hope to work with you later. Okay.
Thank you.